Hi everyone, and welcome to the Mat 211 review on Gauss-Jordan Row Reduction. My name is Julia, and I work for the tutoring centers at ASU. So for today's problem, we want to use Gauss-Jordan Row Reduction to solve this system of equations with 4 variables, x, y, z, and w. So the first thing we want to do, as always, is we want to switch this into an augmented matrix. And remember that each column is going to represent the coefficients of one variable. So we already have this nicely lined up for us with our x's first, our y's, our z's, and our w's. So let's go ahead and build that augmented matrix. So we'll write it over here. We've got 2, 1, -1, -5. And that's for our first row here. And then we'll have our bar, and the answer to the solution for this particular equation is 5. For our second row, we don't have a x here, so we're just going to put a 0 in there. And we'll have a -1 for our y, a 4 for our z, and a 1 for our w. Then we'll have 11 on the other side of our bar. For our third row, we're going to have 3 for our x, 3 for our y, 2 for our z, and a 0 for our w because there's no w here, and then 29. And then for our last row, we're going to have 1 for x, 1 for y, -1 for z, and -1 for w, and then a 3. So let's make our brackets a little bit bigger here, just so it looks right. So we've got this one, bar, and there we go. So now that we have our augmented matrix, we can use our row operations to reduce this matrix. So the first thing I'm going to note is that I know I want a 1 here, and I have a 1 in this position in the first column in the fourth row. So I'm going to go ahead and actually swap these 2 rows, so that way I can just start with a 1 already in the first row's pivot spot. So we would say row 1, swap with row 4, and that gives us 1, 1, -1, -1, and 3. And then our second and third rows are exactly the same, 1, -1, 4, 1, and 11, and then 3, 3, 2, 0, 29. And for our last row, we'll be swapping this with row 1, which is 2, 1, -1, 5, and 5. Great. So now that we have that, we want to first start looking at reducing the first column. So we want to get zeros here and here. So we'll kind of combine steps a little bit here where possible, just because this is going to take forever otherwise. So let's go ahead and do row 3. We're going to subtract 3 times row 1 from row 3, and we're going to subtract 2 times row 1 from row 4. So that would be row 3, can be row 3 minus 3 row 1. Row 4 is going to be now row 4 minus 2 row 1. And this will give us, if we work it out, the matrix. So our first and second rows will be exactly the same. So you have 1, 1, -1, -1, and 3. Got 0, -1, 4, 1, and 11 for our second row. And then our third row, we're going to have 3 minus 3 times 1, so that's going to be 0. Another 3 times 3 times 1, or minus 3 times 1, so again 0. We'll have 2 minus 3 times -1, so that's 2 plus 3 in this case, so that gives us 5. And then 0 minus 3 times -1, which is 0 plus 3. So we'll have a 3 here. And then for our 29 here, we're going to have 29 minus 3 times 3, so 29 minus 9. So we'll have a 20. And the same thing, we'll do exactly the same process for our row 4, except we're going to be multiplying our row 1 by 2 instead. So we've got 2 minus 2 is 0 for the first. We've got 1 minus 2 times 1, so 1 minus 2, so that's going to be negative 1. We've got negative 1 minus 2 times negative 1, so negative 1 plus 2, so that's going to be a 1. And then we'll have a negative 3 here because 5 minus negative 1. Oh, no, that's not correct because this was supposed to be a negative here. That's why that didn't look right. All right, so we'll have negative 5 minus negative 1 times 2, which is negative 5 plus 2. So that's why it's a negative 3. There we go. And then we'll have a negative 1 here because 5 minus 2 times 3 is 5 minus 6, so negative 1. So let's start trying to move a little quicker since I think we've got the basics down now. So I'll wrap down to the bottom here. So for our next, we're going to do, well, we know we want a 1 in this position, so we can just multiply this whole row by a negative 1. So we're going to have row 2 is negative row 2, and that'll give us 1, 1, negative 1, negative 1, 3, then 0, 1, negative 4, negative 1, negative 11 for our second row. And then the third and fourth rows are exactly the same. 0, 0, 5, 3, 20, and 0, negative 1, 1, and negative 3, and negative 1. Great. So next, we know we want to get a 0 in this position, so we can just add row 2 and row 4 to make that happen. So we'll do row 4, going to be row 4 plus row 2. And that'll give us, first 3 rows will be exactly the same. 1, 1, negative 1, negative 1, 3, 0, 1, negative 4, negative 1, negative 11, 0, 0, 5, 3, and 20. And then, of course, we'll have negative or 0 for the first one, because 0 plus 0. Negative 1 plus 1, so that'll be a 0 as well. 1 plus negative 4, so negative 3. And negative 3 plus negative 1, so that'll give us a negative 4 there. And then negative 1 plus negative 11, negative 12. Great. So next, we know we want a 1 in this position, so we can divide row 3 by 1, well, we can divide it by 5, so we can multiply it by 1/5. So we'll have row 3 is 1/5 times row 3. That'll give us 1, 1, negative 1. A lot of time is spent just rewriting matrices when you're doing this with larger matrices, but you want to make sure you're correctly doing it so you're not missing negative signs like I did up here. 1, negative 4, negative 1, negative 11. So, okay, now we have 0, 0. Well, 5 divided by 5 is just 1, exactly what we want. Then we get a 3 over 5 here, and we got a 20 divided by 5, which is 4. And then our last row remains the same. 0, 0, negative 3, negative 4, negative 12. Yay. So let's go ahead and write this back up at the top so that way we can kind of wrap back down again. So we'll just erase, erase, erase. Make some space here. I'll erase the rest of it as we go. So we've got 1, 1, negative 1, negative 1, 3, 0, 0, whoop, nope, 0, 1. Don't want to make that mistake. 0, 1, negative 4, negative 1, negative 11, 0, 0, 1, 3/5, and 4, and then 0, 0, -3, -4, and -12. Great. Let's erase the rest of this real quick. Erase, 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 erase. World's slowest eraser tool. Erase, 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 erase. Okay, great. So now, next thing we want to do, so we got a 1 here, a 1 here, and a 1 here. We want to get rid of this guy. We want to make -3 a 0, and then we are eventually going to want a 1 here too. So let's start with doing the -3 to 0. So to do that, we can add 3 times row 3 to our row 4. Row 4 is row 4 plus 3 row 3. And that'll give us 1, 1, -1, -1, 3, 0, 1, -4, -1, -11, 0, 0, 1, 3/5, 4, and for our last row, we have 0, 0, and then -3 plus 3 is going to be 0, and then -4, so we'll write this one below. So we have -4 plus 3 times 3 over 5, so it's going to be 9 over 5. So that'll be -20 over 5 plus 9 over 5. So that'll give us -11 over 5 here. Now we can erase that. And then lastly, we've got -12 plus 3 times 4, which is 12. So that gives us a 0 as well. Great. So now we want to get this to be a 1. And so the only thing we need to do here is multiply this by -5 over 11. So we're going to go ahead and we're going to say row 4 is going to be -5 over 11 times row 4. And that gives us 1, 1, -1, -1, 0, 1, -4, -1, 0, 0, 1, 3 over 5. That is a 3. And then 0, 0, 0. And then since we're multiplying this by -5 over 3, the negatives canceled out, or excuse me, -5 over 11. The negatives cancel out, and then we have 11 over 5 times 5 over 11. So that ends up being 55 over 55, which equals 1. So we got our 1 there, just like we wanted. And then 0 times -11 over, or -5 over 11 is still just 0. And then we can just write in the rest of these. And 3. Great. So next we want to, so now we have it in, we have all zeros all below the diagonal. We have 1s along the diagonal, and that's what we wanted. So now we need to get rid of the zeros above here. Now it is possible to actually solve it from this point. This is what's called Gaussian form, or rref form is another term for it. And so you can use back substitution starting with the bottom and working your way up, because this bottom is just going to be W equals 0, and then you can substitute that into this equation and just move upwards, remembering that your columns are going to be the coefficients for X, Y, Z, and W here. But let's go ahead and complete it. It actually isn't going to take us too much longer at this point. So let's go through and use the full Gauss-Jordan row reduction to get it, zeros everywhere and 1s on the diagonal. So next thing we want to do, we'll start here again. So we always kind of move left to right. That usually is the easiest. And we're going to get rid of the 1 here and make this a 0. So we can subtract row 2 from row 1 to give us that. The row 1 is going to be row 1 minus row 2, and that will give us, let's see, that will give us 1, 0, 3, 0, and 14 for our top. And then we'll have just everything else will be the same. 0, 1, -4, -1, -11, 0, 0, 1. Oops, it's not in the line there. Let's fix that. 0, 0, 1, 3/5, and 0, 0, 0, 1. And you got a 0 here and a 4 here. Cool. Apologies for my handwriting on that. All right, so next, what do we want to do? We want to get rid of the 3 here and the -4 here. And I'm actually going to do this all in one step since it's 2 separate rows and they're both going to be acted on by a third row. We're going to use row 3 in order to do this. We're just going to, so for the top one, we're going to subtract 3 times row 3. And for the second row, we're going to add 4 times row 3. So that gives us, if we write it out, it's always good to do the notation with the arrow here because it'll just keep track of what you're doing a little bit. So that would be row 1 is going to be row 1 minus 3, row 3. And row 2 is going to be row 2 plus 4, row 3. And if we work that out, we get 1, 0, 0, -9/5 here. 0, 1, 0, 7/5 here. 0, 0, 1, 3/5. And 0, 0, 0, 1. And then we have a 2, a 5, a 4, and a 0 here. So the last thing we need to do is we need to get rid of these 3 because we don't want any values above our 1s, or non-zero values, that is. So in this case, we're just going to add or subtract a multiple of this row to each one. So usually by the time you get to this point, it's fairly simple to do. So we've got row 1 is going to be 9/5 times, oops, we want to add it in there first, that's important. So it's going to be row 1 plus 9/5 times row 4. Our row 2 is going to be row 2 plus, or minus, because this one's a plus, so minus 7/5 row 4. And our row 3 is going to be row 3 minus 3/5 row 4. A little crammed in there, but hopefully you can see it. All right, and that should give us 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0. Oh, that's not a 0. 0, 0, 1, 0. 1, 0, and then 0, 0, 0, 1. And since this is a 0 here, none of these change, so we just have the same values here. So 2, 5, 4, and 0. And that's it, we're done. We have zeros above and below the ones on our diagonal here. So we are in Gauss-Jordan form now, Gauss-Jordan form. Great, so how do we interpret this? Let me make a little space here and we will just clear out enough that we can write something here. Perfect. All right, so we've got a 1 in the place of the x. So remember this is x, y, z, and w are the coefficients here. So w. And so these end up, since we only have ones in each of those rows, these end up being the solutions for each of those. So we can rewrite this back in the system as a system of equations as x equals, well, all these are 0, so just x equals 2, y equals 5, z equals 4, and w equals 0. And that is the solution to our system. Yay! All right. So before I go, I just want to remind you all that if you are looking for any additional tutoring or academic support at ASU, please visit the Tutoring Center website, tutoring.asu.edu. And you can either get to the tutor search tool by off of this main page or by going to this full link. And the tutor search tool will allow you to find tutoring services for your specific course. So thanks so much and have a great rest of your day.